Hi everyone. So we are getting towards the end of this topic about resistors in series and parallel. And what this is the extension work. So we're doing more complicated questions involving combinations of series and parallel circuits. So if it's just a simple series circuit, you can deal with that. That's quite straightforward. Parallel circuit, a wee bit more difficult, but you can cope with it. But when you get a combination of the two, it gets a bit more tricky. So this is what this whole point about it is. I'm just going to go through like networks of resistors and hopefully, point you in the right direction. So what it says there, hopefully you've done the simple stuff, the more straightforward examples, and you're ready to tackle the more complicated extension questions. So spend a bit of time going through this PowerPoint with me, and hopefully you'll be able to cope with just about any type of question. I'm not going to go over any past paper questions at this stage, but that would be the next thing to do after doing this. So first example is we've got a network of resistors. We're only looking at the resistors. We're just leaving the battery and everything else out of the circuit. So we're just looking at the network of resistors, and we've got 2 points X and Y. So the question would be something like, so work out the total resistance between points X and Y. So what you've got is you've got two 6 ohm resistors in parallel, and then you have another 6 ohm resistor here added on. So the way you tackle these is that you always look at the parallel part of the circuit first. So the parallel part is obviously the 6 ohm and the 6 ohm. And so what you need to do is work out what the resistance of this part would be, and then we go on from there. Now, the next stage is, if you remember from, I think, well, I've kind of got mucked up with the order of the videos, but one of the earlier videos, there's a thing about remembering that if you've got two resistors the same value in parallel, then to work out the total resistance of that part, you half one of the values of the resistors. So this one's dead straightforward. Nothing wrong with doing the calculation, but there's no need, because you should recognize or remember that if you've got two resistors the same in parallel, then the combined resistance of that part is 3 ohms. And so this network of resistors could be redrawn so that instead of the two 6 ohms in parallel, you can replace that with a 3 ohm. It's going to have the exact same effect. So there's two 6 ohm resistors in parallel are replaced by the 3 ohm. So now your network of resistors looks a lot simpler. So you've got a 3 ohm in series with a 6 ohm. So the total resistance between the X and Y will just be the 3 plus the 6 added together, because they're in the series. So your total resistance at that point, or between these 2 points, is going to be 9 ohms. Hope that's okay. Right, example 2, a bit trickier. Same sort of idea, but this time the resistors in parallel are not the same. So we have to do a calculation. But again, same as we did previously, you look at the parallel part first. So you start by looking at the parallel part of the network, which is the 60 ohm and the 30 ohm in parallel. So write down the parallel resistors in parallel equation, which is your 1 over the total resistance equals 1 over R1 plus 1 over R2, which gives you, you then substitute in the numbers, which is going to be 1 over 60, because that's R1, doesn't really matter which way around you do it, 1 over 60 plus 1 over 30. And I've tried to show you the calculator screen, hope that's showing up for you okay, but basically if you do 1 divided by 60 on the calculator plus 1 divided by 30, then your calculator, again depending on what model of calculator you've got, etc., it comes up with the 1 over the total resistance is 1 over 20. There's various ways you can do it in the calculator by doing fractions and stuff like that, but I always think that just bunging the numbers in as it is in the equation there, it's the most straightforward and the easiest. But you're free to do whatever way you want. So therefore, remember that's what 1 over the total resistance is. So to get the total resistance, what you've got to do is flip that round. So it's going to be 20 over 1. So that means the total resistance of this parallel part is 20 ohms. And so therefore the last line, I've done it as an equation this time too, because so this part of the resistance network would be a 20 ohm. So you could replace those two parallel resistors with a 20 ohm resistor. So you've got a 20 ohm and a 10 ohm in series. So hence why you've got the resistance in series equation there. And it's 20 plus 10, which gives you the total resistance between X and Y in this circuit would be 30 ohms. Hopefully you're seeing it's all quite straightforward, all quite simple. Last one is a bit more complicated, not much more, but so this time you've got a network of resistors between X and Y, which includes 3 in parallel and then 3 in series. So just exactly the same procedure, there's just maybe a wee bit more to do in this one. So this time we have a plus 1 over R3 because we have 3 resistors in parallel. Again, we're focusing on the parallel part of the network of resistors. So that's my attempt at a wee red circle round about it, never mind. And so we're dealing with these 3 resistors, the 20 ohm, the 30 ohm and the 60 ohm in parallel. So that's what you substitute into your parallel equation. So it's 1 over 20 plus 1 over 30 plus 1 over 60. And I've picked values so that we get a straightforward answer, that it's going to be that the 1 over the total resistance is 1 over 10. So that parallel part of the network of resistors, the 60, the 30 and the 20 all in parallel, could be replaced by a 10 ohm resistor. So if you imagine doing that in your head, so now you've got a 10 ohm here and a 60 and a 30 and a 20. So the last part is to work out the total resistance between X and Y. You're going to do 10 plus 60 plus 30 plus 20, which hopefully, if I've done my maths right, will give you a total resistance between X and Y of 120 ohms. So basically that's how you deal with more complicated networks of resistors where it's not just series and it's not just parallel, but it's a combination of the two. So in this case, you generally focus on the parallel part first, work out what the one resistor would replace these 3, and then work it from there. Okay, so good luck with the extension questions, and then there'll be a quiz on Thursday for you to complete. Okay, see you again. So sorry about that, mucked up from the previous slide. I thought there was only 3 examples, but then this one came into my head and I thought it'd be a good idea to add it on. So hence why it's daylight now and I've had a haircut. But anyway, so this one, what you're given is 2 resistors in parallel, a 20 ohm and in parallel with something else, R2 we'll call it, and you're told that the total resistance in this case is 15 ohms. So this is a slightly more complicated, slightly more difficult one again. So I'll talk you through how you do this, all right? So first stage, this resistor's in parallel. We know it's a parallel resistance because there's a junction there. So we're going to write down the resistors in parallel equation. 1 over the total resistance equals 1 over R1 plus 1 over R2. Now in all the other examples I've shown you, you've always wanted to calculate the total resistance, but not in this question because we're given the total resistance. So the next line, as you would always do, is you substitute in the numbers you've got in the correct place. So in this case, that then gives us that we've got 1 over 15, because that's what the total resistance is, equals 1 over 20 plus 1 over R2, where R2 is the unknown thing that we want to find, okay? So basically we want to have 1 over R2 on its own, on one side of the equation. So the 1 over 20, we're going to move it over to the other side of the equation. So change side, change sign. Difficult to say that. So that's where the wee arrow is indicating that the 1 over 20 has to move over to that side of the equation. And you should remember from your math skills that if you change the side, it changes sign. So it becomes 1 minus 1 over 20. So this line here now becomes that 1 over 15 minus 1 over 20 equals 1 over R2. Now I'm going to go through this in a really long, sort of winded way, just so we're all clear what we're meant to be doing. So the next thing I'm going to do is I'm just going to write this whole thing round the opposite way. So I've not done anything else other than just written it so that 1 over R2 is on the left-hand side and the 1 over 15 minus 1 over 20 is on the right-hand side, as opposed to there when it was the opposite way around. So now you've got the calculation to do. So you put the 1 over 15 minus 1 over 20 in the calculator. Hopefully it shows up on the screen there. So 1 divided by 15 minus 1 over 20. I've said to you before, there's a number of different ways you can do that. I'm happy for you to just do it like that. I think it's really straightforward. And hopefully that then gives us that 1 over R2 equals 1 over 60. Again, I've picked the numbers, so we've got nice round answers to come out. So we're nearly finished because 1 over R2 equals 1 over 60. So remember, we want to find R2. So what you're going to do is you're going to flip that round. You're going to invert that so that it's going to be, the final answer is that the R2, the value of that second resistor there, would be 60 ohms. So therefore, a 60 ohm and a 20 ohm in parallel gives you a total resistance of 15. They work out to be nice, easy numbers. And again, just to remind you that the 15 ohms, the total resistance is less than any of the two resistors there. Okay, so these are a wee bit tricky, a wee bit difficult, but not with, not beyond your capabilities, I'm sure. So, okay, that's definitely finished now. So you now can go on with trying the extension questions. Remember, if you need any help or want to ask any questions, then feel free to ask your own teacher, and by email or by Teams or whatever. Okay, and I'll catch you next time.